Welcome to this month's monthly Kube Chat. This webinar is called Kubernetes Applications, Best Practices for Cost-Effective Scaling. And today your host will be Patrick Tavares. He is a solutions engineer here at Kubecost. And before I kick it off over to him, I did want to let everyone know that we will be recording this session today. So if you cannot stay for the whole thing or want to forward it to someone else on your team, just be on the lookout for that link that we'll send after the webinar today. We will save some time as well at the end for some questions. So feel free to submit questions throughout the duration of the session, and we'll cover as many of those as we can once we get to the end. So with that, I'll go ahead and kick it off over to Patrick.
All right, great. Thanks, Dee. So I'll echo her sentiments. Good morning, good afternoon, or good evening, depending on where you're located. So today, just want to take you through a quick agenda, what we're going to be covering. We'll start with some intros, a little bit about me, why or how I kind of come up with some of our best practices. We'll talk a little bit about the history of Kubecost, and then we'll just kind of jump into discussing scaling in Kubernetes, how we go about right-sizing resources, talk a little bit about that cost to performance, trade-off decision-making process, discuss a little bit around FinOps alignment, and how this all kind of fits in with that, and then and touch on a little bit about autoscalers in Kubernetes, and then lastly we'll just wrap up with a little Q&A like Dee mentioned. So with that, let's get started. So as Dee mentioned, my name is Patrick Tavares. I am a senior solutions engineer here at Kubecost. Got over 25 years of experience in the IT industry. I've done various roles from designing, building, integrating, and actually supporting basic application and more complicated application systems for various Fortune 500 companies. I've had the privilege of working for a few of those, namely Deloitte, Verizon Business, Red Hat, and now Kubecost. I've kind of had a pretty diverse background, especially when you consider that Red Hat was acquired by IBM. Technically, it was part of IBM as well. So from that, I was able to see kind of how we've done things from the old school way of doing things into now this kind of clustered cloud environment, and kind of various levels of scaling in between there. So I'm kind of pulling for some of those experiences, but I've also worked with tons of clients and seen how they've done things. And here at Kubecost, we've also worked with a bunch of customers where we've kind of seen some of the best ways of approaching some of this stuff. So I'm on LinkedIn, as you might imagine, so reach out, connect with me. But with that, let's talk a little bit about Kubecost. So Kubecost was started by a couple of gentlemen that came from Google. They both worked on the Borg project before working on Kubernetes. So if you're not familiar with the Borg project, that was kind of the predecessor to Kubernetes that was used internally within Google. And so their experiences there, and then of course working on the Kubernetes project, kind of opened their eyes to a need for a tool that could provide some insights around cost visibility and optimization and things of that nature, right? And so they decided to start Kubecost in 2019, and we've been focused on providing that cost visibility, or originally started providing that cost visibility and insights from a Kubernetes perspective, but now we've kind of broadened that scope into not just Kubernetes, but other aspects of the cloud as well. But we do run on any Kubernetes-based environment. So that's, your major cloud providers, their flavors of Kubernetes, as well as on-premise, / air-gapped environments. And so as you might imagine, that ties into some of the more enterprise distributions that are out there. But also really any flavor of Kubernetes, including if you've rolled your own. We have kind of the privilege or the honor of being able to say that we help customers across the board manage over $3 billion in spend in their Kubernetes environments. And you can see here in the kind of the logo list, the various diversity and the different size of organizations that we help manage spend with. So, but anyway, enough about that. Let's jump into the kind of the meat of the presentation today. So the title of this monthly session is scaling cost effectively. So what do we mean by that, right? So before we kind of define that, let's talk a little bit about scaling in Kubernetes. So effectively, you can either scale vertically, which is scaling up and down, scaling horizontally, as scaling out and in, or both, right? All of these things cost money in terms of the types of and the amounts of resources that you're allocating or utilizing, right? So I make that allocation or utilization distinction because it's important. You really should look at whichever one of those two is higher, because at that point, that's what you're paying for effectively for the various cost groups that we're going to talk about. But we'll touch on that in more detail in the slides to come. But in most cases, when you scale an application, unbounded spend, basically just throwing as much resources as you can, does not equate to unbounded performance, right? So most applications have a sweet spot. So if you look at this graph that we kind of have here, there's an area where as you spend, you actually get some pretty significant gains in performance. But then you'll get to a point where you start spending more than that and you still get performance gains, but they're more expensive gains, right? So now you start to reach this area of diminishing returns for your spend. And then in a lot of applications, you'll get to the point where you can continue to spend more, but you get very little, if none. There's a chance of getting no additional performance gains. And in that scenario, that's really where you're starting to tread into the over deployment, wasted spend space, right? And so to scale cost effectively, you need to know where these inflection points are, right? You need to know where it is that you're actually getting the biggest bang for the buck, where it is you're actually starting to see these diminished returns. And then, of course, where is it that I'm now wasting dollars? And so in order to do that, you've got to be able to collect the data in some pretty decent detail, which we'll talk about as well. But all this kind of together forms our definition, or allows us to formulate a definition, if you will, right? And so the way that I would define cost-effective scaling is basically spending the least amount of money possible to achieve the desired performance levels that you need to ensure a satisfying user experience, right? And so it all kind of ties together there. But moving on, now that we've kind of defined cost-effective scaling, let's talk about our approach to getting there, right? So if you've seen the DreamWorks movie Shrek, you may be familiar with a scene in there where Shrek explains to Donkey how ogres are similar to onions because ogres have layers. I like to kind of equate that to Kubernetes based applications because they too have layers, right? So in my mind, cost-effective scaling starts with understanding the different layers and then how to achieve or address scale as it makes sense at each particular layer, right? And so the important thing to understand is that as you address things within the innermost layers, they actually do have a trickle-down effect to the things that the surrounding layers, right? So as you tweak your application, that influences the way that you can right-size your containers. And then when you right-size your containers, that also influences the node sizing and that sort of thing, right? But in order to achieve kind of ultimate cost-effective scaling, you really have to address tuning at each of those layers, right? And so it starts with the innermost layer at the application side, and then you work your way out. And then, of course, like we mentioned earlier, the bottom line is that there is that trickle-down effect, and so you got to be cognizant of that as you kind of address it. So now that we know a little bit about the layers, let's start with the application layer, and let's talk a little bit about tuning the app. So there's kind of two different ways that you can approach tuning an app. Of course, the first way is kind of at a code level, which requires either access to the application development team or you being part of that development team. As folks on the platform side of the house, probably not going to be able to do any code tweaking or not be, at the very least, like able to do it. There may be some other options there for tuning the app from a more of a, like an environment or runtime settings that you can kind of tweak. But either way, both of those options for tuning the application should be explored, because what that allows us to do is effectively adjust that performance curve, right? And so what that buys us is, as you can see here in the graph, we can actually get steeper curves where, the more we spend, the more performance, or the larger the increase in performance we can get, versus say, more shallower curves where, if that's all that we have to work with, it becomes a little bit more expensive to do, get your performance gains by scaling up or out. But it all starts with that app. And if we can influence that curve in a way that's favorable to us, then we can actually get better inflection points around bang for the buck, and as well as like reducing, over deployment, and then maybe even shifting the point of diminishing returns in our favor to where we can actually have a smaller space there, right, from a diminishing return standpoint. So ideally, your app teams do get involved and they kind of help do some tuning at the code level, especially making sure things like memory leaks aren't part of the equation or runaway CPU scenarios are kind of addressed, right? And usually this is done through proper load testing as well as just kind of looking through their code. But bottom line, some sort of application tuning needs to be addressed so that you can get off on the right foot, so to speak, right? Make sure that you've started off with a good base, because then comes the next part, which is right sizing containers. And so when we talk about right sizing containers, what we're really talking about is matching your actual utilization to the size of the resources that you're allocating, right? Or as close to 100% efficiency as possible, right? And when we talk about efficiency, we're really talking about, again, the resources that you're actually utilizing divided by the resources you requested, and that kind of gives you that percentage mark. Now, while the goal is to get as close to 100% as possible, you do need to know your app's requirements and take those into account, right? So your apps may have very specific latency or response time requirements, in which case, the closer you get to 100%, maybe you start to see those numbers creep up above thresholds that you're comfortable with. So you got to take that into account. You may also want to have some sort of margin of safety headroom, right? To where you're not comfortable running at, say, 95%. You're more comfortable just based on the way that your operations team works. Maybe more comfortable at, like, say, 80% utilization efficiency. Whatever that is, you should strive to get to as high of efficiency rating as possible, so that you can actually, again, trickle down to the next layer in terms of having a good starting point, right? So the other thing to keep in mind when you're doing right sizing exercises, especially in your containers, is you've got to have data to make this informed decision. And usually, especially with new applications, you don't really have any data to kind of start with, right? So the best thing you can do is just deploy the application with the best guess based on developer feedback, or maybe what you think the application is going to be consuming, and then start that data gathering exercise, because that's where you need to use that data to then make refinements to the scaling later on, right? And then the important part about that data gathering exercise is you need to make sure that you observe a long enough time window that encompasses, like, your peak periods of utilization or other important times of use, right? The worst thing you could do is make decisions based on data that doesn't include critical time periods of your application's use, because then now you're setting yourself up for a potential issue with user experiences. So once you've got your containers right sized, the next step is then dealing with the node layer, right? And so when we're talking about right sizing nodes, efficiency comes into play here. It's a little bit different though. Whereas efficiency was, resources used divided by resources requested at the container level. With nodes, we're really talking about kind of idle resources that are you're trying to optimize out, right? At Kubecost, we refer to those as just idle shares of resources. You may hear some of us refer to those as white space in the nodes, but the idea of right sizing the nodes is a combination of either shrinking the same node type, but making smaller instances of them so that you can right size out those white spaces. Or if your nodes perform better on different your applications perform better on different node types, making the decision to kind of switch to a different node type that's more appropriate for your application. But you've got to have the data to support that too. And so this is where tooling becomes very important to understand how well your applications behave in these different scenarios, right? But the other thing to keep in mind is there's also requirements that can be directly impacted from a node standpoint. When we're talking about the app or the container layer, tuning and making sure that you account for things like runtime and response time and latency. At the node right sizing layer, you're now more concerned with things like uptime and mean time to recovery, right? So if a node goes down and you have apps that are running on them and there's no redundancy built in there where they're on other nodes as well, now you've got an outage issue, right? And your application may have, an SLA of 5 nines, in which case you would need to make sure that you've got multiple nodes running your apps. And now you might have to actually leave a little bit of white space in there purposely so that you've got redundancy in your overall application. So again, things to keep in mind when you're trying to do your right sizing exercise at the node level. But the node level, last comment on that before we move on, the node level is really kind of where the cost aspect is most concrete, right? This is where the rubber meets the road, so to speak. When you change your quantities of nodes and you change your types of nodes, you're directly impacting the cost at this point because these are the things that you're actually consuming. Whereas when you change things at the container level or the at the application level, they can indirectly impact the right sizing down at this level. So again, it kind of shows that trickle down effect is in full force. But once you get down to the node, this is really where you do everything to kind of affect the node sizing choices and types so that you can actually affect the cost at that point. There's other aspects of that too, like network transfer costs and storage. But from the standpoint of scalability, usually the biggest things are handled in the stack, the layers that we're talking about right now. So then you've addressed all the different layers from a scalability standpoint. And now what you're trying to do, well, the reason why we go through that exercise of kind of collecting data at each layer is so that we can actually start to understand the best places to make changes so that we can do the scaling cost effectively, right? And so where this starts is really the two kinds of data that we've been collecting along the way. There's cost-based data, performance-based data, and those are the two bits of data or types of data that align with that cost versus performance curve graph that we've been seeing. But in my mind, cost allocation is kind of equivalent to, or the analogy that I like to draw is kind of splitting the dinner bill at the end of the night, right? When you go out with friends, right? So you've got this one big bill at the end of the evening, and really to be effective in figuring out how to tune and maybe optimize your spend at future dinners is to make sure that you know exactly how much your group spent or you personally spent at the dinner table, right? And the way that you do that is you would allocate the cost from the total. So each in the business world, as we're really talking about allocating the cost of your underlying Kubernetes spend and your cloud spend to the different application teams or to the different applications themselves, or maybe even specific business units, right? But the idea is that you need to gather this data so that you can effectively, at the application level too, right? Or at the whatever grouping makes the most sense for you, so that you can be efficient in making the decisions from a scaling perspective, right? And so that data will help you map out that cost curve so that you can see what your current spend is at the given performance levels, right? And so aside from kind of mapping out the cost curve, the other reasons why having solid cost allocation data is important is because it allows you to be more granular with your budgeting and forecasting. So this actually comes into play when we start talking about FinOps and kind of part of that FinOps philosophy of accountability. Usually the accountability side of things stems all the way down to specific teams and applications. And then maybe you've got a chargeback initiative or a showback initiative or something like that, where you need to be able to charge your teams back. Well, having granular cost allocation, kind of playing back to that splitting the dinner bill at the end of the night, having that granularity for charging back allows you to prevent the situation where like one team came to drink water that night, but now they're being forced to split the bill for a bill that had some expensive wine they didn't drink, right? I think we can kind of relate to scenarios like that. So the idea is if you've got the data, you can avoid those situations. And if you've got the tooling to help you support getting that data easier, it becomes less of a hassle and becomes much more manageable to do that from a cost allocation standpoint. So once you've got your cost allocation data, the other thing that you really have to shore up is the resource utilization information. This is probably the area where most platform teams have the most experience because we've all kind of been running tooling since the very beginning that allows us to see, how much memory are my applications using, how much CPU. The difference here, or the nuance here, is that you can take that information. It's important information, but you still need to be able to apply it down to the same granularity that you're applying at your cost allocation level. Because when we talk about that cost versus performance curve, it really is they both have to be equal, right? You have to address that at a per application level or per whatever your cost grouping level is so that you can adjust for those, right? You could potentially adjust at much higher level of cost grouping, like at the cluster level, or kind of more generic, like the namespace level or Kubernetes side. But the more granular you can get, the more effective your cost versus performance in your cost-effective scalability will be. But it all comes down to collecting the data and showing that data at that granularity. So once you've got a plan for both, cost allocation, data gathering, and the resource utilization, now you can actually answer the question of, cost versus performance, and is it even possible to optimize for both? And so the short answer is, in most cases, it is possible to optimize for both. You can have your cake and eat it too, to a certain extent, right? And what I mean by that is that most of the environments that I've been a part of, or that I've seen from my customers, over deployment was the norm. And so they were spending a lot to get what they thought was the right amount of performance. But after some evaluation and kind of looking through the data, they saw that just kind of really quickly, they could reduce the amount of resources allocated and still get the exact same level of performance. So in that scenario, it was a quick win-win. They optimized for both. They still maintained their level of performance, and they got cheaper cost to operate it at. But they wouldn't have known that they could do that without figuring out, collecting the data and then figuring out where those inflection points are. So the graph on the right kind of represents that potential, right? So we've got this potential where they've scaled up, a fictitious user or somebody has scaled up to a point and scaled their container replicas out, and they didn't need to. They could actually run with less replicas, and they can make the decision on whether to size their containers and nodes down to where they can get focus on that area where it was best bang for the buck versus that little sliver of green where it was diminishing returns, right? And on the right side, kind of focuses in on a scenario where the app teams got involved, or the platform team had access to be able to do a little bit more app tuning, and they were able to influence the application's performance curve more favorably towards them, so they could actually increase the performance and for the same cost, and they could actually reduce costs and get similar performance levels and kind of have that cake and eat it too. So none of this is possible without actually having tooling to help you collect that data. And I say tooling, there's options there, right? Obviously, from the Kubecost perspective, we have a take on this, but as long as you're collecting the data, that's the important part of that, so that you can actually make those informed scaling decisions. So we've answered the question of, can we scale effectively? So the next topic I want to kind of cover is FinOps, right? And where does this fit in with this whole idea of scaling cost effectively? So if you're not familiar with FinOps, the FinOps Foundation has a pretty detailed definition that I'd like to share with you. So they say that FinOps is an operational framework and cultural practice which maximizes the business value of cloud, enables timely data-driven decision-making, and creates financial accountability through collaboration between engineering, finance, and business teams. So that's a pretty lengthy definition. I like to kind of boil that down in my own words and kind of call it FinOps is essentially running your applications as cost effectively and performant as possible, using data and a diverse team of skilled folks to actually help guide that decision-making process, right? Regardless of how you define FinOps, I actually agree strongly with their take on the fact that it just kind of boils down to three key pillars or three key ideas, right? And that's inform, optimize, and operate. Now, if you're familiar with FinOps and you've been kind of listening to the presentation so far, you may have picked up on the fact that we've secretly already been talking about these three phases along the way, right? We just kind of covered them in reverse order. But from the standpoint of inform, what that really boils down to is gathering the required, cost and utilization data so that you can then make informed decisions in the next step, in the next phase, right? So the next phase being optimize, which is, all right, well, how do we cut down on cost? How do we right size things? How do we didn't really touch on this in the previous slides, but the other benefits of having that data is now you can also see, is there just flat out resources that we're not using at all that we can eliminate, right? Maybe we've got some workloads in a non-prod environment that were put out there for for testing a concept and we just never shut them down, or maybe there's IP addresses or PVs that are just orphaned, they're not mounted anywhere, they're not attached to any CNI. Like these are things that once you've got the data collected, you can then take optimization steps on. Not technically, maybe not scaling from an application standpoint, but when you're talking about scaling up an environment as a whole, that definitely plays into cost-effective scaling for sure. And then the last part of last of the three phases is operate. And so what we're talking about here is taking everything we've learned from the information, all the optimization exercises we've done, and then putting them into practice, right? Operating at scale so that you can, get the job done at the end of the day, right? There's usually some other aspects of operations that most organizations also roll into this, things like governance around like alerting and budgeting and other capabilities that allow you to kind of make sure that you're staying on track and keeping your all your application costs in check. But the other thing here that's important to understand is that this isn't a one and done process. It's a continuous iterative process, right? So most of us handle applications that change over time, right? Whether that's new features or maybe usage patterns change, or maybe we're just kind of changing the way that we deliver them. Regardless of how they change, the fact is that they change. And so that's why there's this need for a continuous cycle. And that's where the three pillars of FinOps really come into play and really speak volumes to that. So that's kind of the FinOps angle of scaling cost effectively, right? So last major topic I wanted to cover is around autoscalers. So when we're talking autoscalers, obviously we were talking scale earlier, vertical, horizontal, and there's equivalents in the Kubernetes world. So if you're using the vertical pod autoscaler or the horizontal pod autoscaler, or maybe even just kind of a node level automated scaling like cluster node autoscaler or something like Carpenter, right? This is kind of what we're talking about here. And so I get the question a lot regarding cost-effective scaling. They'll say, Patrick, I already use these auto scaling capabilities within Kubernetes or my cloud provider. Isn't that enough, right? Isn't that cloud auto scaling at its cost-effective way? Because I can only I can scale up and only pay for the resources I need, and then scale back and basically stop paying for resources I no longer need. And so my answer to that is yes, that is an aspect of cost-effective scaling, and yes, it does work, and they're fantastic tools. But the fact is that if you haven't done the work that we've already talked about to this point, then all you're really doing is scaling that inefficiency, right? You're multiplying whatever inefficiency, whatever overspend that you have in your instances and in your nodes, you're just multiplying that out. So I'm a big fan of analogies. I like to kind of equate this to hearing about people talk about how they like to buy in bulk, right? They'll go to their local bulk wholesaler and they'll buy their favorite food and they'll say, look how much money I saved. But then they only eat half of what they bought and the other half goes bad. And so really all they ate was more expensive now than if they just bought in smaller quantities, right? So the idea is that your unit cost still is expensive if you haven't done, or more expensive, right? If you haven't done the scaling capability to get, or the tuning capability to get your stuff right sized down, so that then you could, scale out with the autoscaler more efficiently. So, but anyway, hopefully that makes sense. With that, Dee, I think that's all I've got to kind of share today. We can kind of move on into some question and answers.
Awesome. Thanks, Patrick. So we did get a few pre-submitted questions. So we're going to start with a couple of those, and then we'll also tackle some of the ones that you all submit live. So the first question we got over here is, I'm seeking a way to structure KPIs and metrics for Kubernetes price/performance and governance. Do you have thoughts on how to calculate a minimum viable infrastructure or a type of recommendation engine along these lines?
That's a good question. So that kind of ties back to one of the key points I brought up around container right sizing. A lot of times if you don't have any data to start with, you just have to deploy, right? Use your best judgment based on what you do know of the application, and try to get as much information from the app teams that are going to be involved with whatever applications you're trying to structure some KPIs around. But the most important thing is you just got to start collecting data, right? I think that was kind of one of the underlying themes of what we were talking about earlier, because if you don't have any data, it's going to be a little bit of throwing the dart against the wall in terms of trying to identify where those breaking points are for, like, the best spend for performance versus where are you starting to see diminished returns, where you can still get performance and still be more expensive for it, or where are you just throwing away money, right? And so the way to kind of do that is just to kind of get started and start gathering your knowledge around that particular application so that you can calculate what those things are, right? And it comes down to collecting the data. A lot of us are going to be coming from, like, if you're like me, an old timer, you came from physical and then the virtualization world. Virtualization, when we went to containers, we all started with just sizing our containers like the VMs that we had. That was a start. It wasn't the best start, but it was a start. And then from there, we're able to gather data and then more effectively, tune our KPIs from that. So hopefully that answers the question.
Great. We got a couple live here that I'm going to switch over to as well. So Ryan asked, will it be possible to get the presentation after we're done here? And yes, Ryan, I will send out a recording of the webinar after, but I can also send a PDF of the deck for everyone. The next question here is from Tiago. What is idle cost in Kubecost and how to reduce that?
Yeah, that's a good question. So Tiago, idle cost is, it kind of depends on how you look at it, right? And we actually can provide some follow-up information how we calculate it. We do use the Kubecost spec, which is part of our upstream open source project, the Kubecost CNCF project. But in essence, we calculate idle cost as whatever white space is left over in the nodes. And then we take all those white spaces and add them up and show them to you, depending on how you're deciding to break out your cost, right? So let's say that I've got a node that has, 16 cores, full cores of CPU and, 128 gigabyte of RAM. And all the workloads that are happening to run on that node at a given point in time are only using up 14 full cores and 64 gig of RAM. Then whatever's left over will determine to be the idle cost of that node, right? And so we do that on a per node basis. And then depending on how you're grouping your costs, we'll represent it as, adding it up and averaging it out. Again, it just depends on how you want to represent your cost.
Awesome. Thanks, Patrick. I'm going to shift back over to some of these pre-submitted questions now.
Okay.
So the next one we have here is, how can I architect the resource usage of my pods before even knowing the demand it will receive while optimizing them for cost? This trade-off comes to me every time I'm bringing a new project to Kubernetes and we still have no metrics available.
Yeah. So it's kind of similar to question one there, right? You've just got to get started. That's the important thing. And you got to get started with your best judgment, right? I mean, it's an iterative process like we've talked about. We're all, depending on our experience levels, we'll have a good idea of where we think we need to start. There is some tooling out there, like Kubecost actually does provide a capability of at least doing a cost estimate based on what your deployment manifests look like. But that won't be enough to kind of show you where maybe you can tweak performance. The only thing you can do at tweaking performance is watch the application run for a little while and then see if you're way over deployed, or if maybe you even need to deploy more resources because you under deployed. But from a cost estimation perspective, we can at least get a starting point there before you even deploy it. And then after it's been deployed, we can then use something like a Kubecost or other tools to kind of show you your utilization along the way, and then use that to kind of shape future refinements of your app settings. So.
Awesome. Thanks, Patrick. I'm going to tackle one more pre-submitted question here, and then we'll strip back over to the live questions. So this one said, can you comment on using automation in non-prod, such as auto-scaling, scheduling, and scheduling scaling, etc.?
Yeah, that's a good question too. The non-prod use cases are slightly different, right? So when you're trying to balance that performance for cost, chart that we were looking at, usually in prod, you absolutely cannot affect your user experience because a lot of times those production applications are tied to frontline revenue for the company or, whatever. But in a non-prod environment, you can withstand a little bit of latency, or you could withstand potentially some downtime, or maybe you've got a lot of kind of experimentation in your non-prod environment where it's throwaway stuff, where once you've proven out a concept, you can effectively throw things away. And so automation there can kind of approach it differently, right? Like I can shut things down when my developers aren't working versus like I need to keep prod up and running 24 hours because I'm trying to run a business, right? So maybe there's peak times and non-peak times that you can take into account for a non-prod environment, or maybe again like there's lots more idle or orphaned resources in a non-prod environment because there's just things that are no longer being used. Regardless, like you've got to have something that can show you that, expose that information. And so the idea is gather that data, and then you can effectively run different types of automations. It's a different cost savings use case in non-prod that you can attack pretty well with the process that we already talked about today. So
cool. Thanks, Patrick. Okay, I'm going to pull up a few of the live ones we have here now. So this is from Tabish. Says, hi, my question is, my PostgreSQL pod is reaching to their memory limits based on how much I am providing. If I am providing 2 GI, it is reaching in 3 days. If I'm providing 4 GI, it is reaching in 6 to 7 days. How do I implement auto scaling in that, or how much memory I should provide for better performance and cost efficiency?
yeah, it's a good question, Tabish. This looks like a scenario where your application it would just continually grow unbounded and unchecked unless there's something put into place here. I would personally take this back to your app teams, because this one's tough, right? The only way that you can, as a platform person, the only controls you would have in this case would be to put like limits or on the resources, and at some point you may run into an unkill scenario, right? So this is more one of those scenarios where I would consult with the application team that's driving this Postgres consumption and work with them to figure out what's going on, because they may not realize that they're growing in such an unbounded way, and that can actually cause issues in the future, right? It's almost equivalent to a memory leak, right? In a single app, if it wasn't writing unbounded data to a database, like the app just continually consumes memory. There's nothing you can do about it aside from just throwing more money at it. But at some point, that curve is going to be way into the negative in terms of wasted spend, or the spend that you're spending on getting those resources is not going to be worth the improvement in performance. So that's something that I would definitely take back to the application teams to try and correct.
Nice. We have another kind of a long one here. Sorry, Patrick. Here's the next one we got from Anonymous. In my company, the EKS platform team allows the application teams to set their compute allocation levels, and each application gets provisioned into their own containers. Isn't there a way for the platform team to manage the underlying EC2 capacity based on daily utilization levels rather than based on allocation capacity requirements?
So the short answer to that is there is, but it's not going to be like a straightforward process, right? You still have to, and by the way, this is not uncommon, right? Most development teams are considered they're experts in the apps that they develop, right? So they're going to be looked at until you've gathered enough data, right? They're going to be seen as the authority in setting the resources for the application. It's not until you've actually seen the application running for a while, or if they've done some testing on their own where they generate the data right through a load test or something. It's not until you've gotten that data that you can then take back to the app team so that they can see that, hey, your application is performing, and it performs at, let's say it performs at this level and you're given this much resources. Well, we can probably take the resources down and get closer to the actual utilization curve. And so you can take that data and then apply it to, again, the underlying EC2 capacity. What we're really talking about is kind of the node level in that Kubernetes application, or the node layer. And so you have to kind of start at the top layer and kind of work your way down as effectively as you can. And so from there, you can use tools like Kubecost to make recommendations on the type of EC2 capacity that you should run your applications on top of. But until you get the data to then take back to your app teams to say, hey, look, you're requesting these resources, you don't need all these resources, and here's why, right? You've got the data to kind of back up that claim. And then every battle with dev teams is a little bit of a negotiation process, but at least you've got data to kind of stand on to kind of take back to them and say, hey, look, we don't need these nodes. We're going to try and run these other nodes instead based on the capacity utilization that we've seen in your application over the last, however many days you want to look at.
Awesome. Thanks, Patrick.
Sure.
We have one more question here, so we'll end with this last one that we got live here. So this is from Pavan, and they asked, what's the best way to manage EKS nodes provisioning costs when using autoscaling in a multi-tenancy scenario, mainly on sudden spikes every time?
That's a good one too. So I guess the question is, do you have, or the questions to ask are, do you understand how the application, you have to have a good understanding of like what the major indicators are of usage, right? So most of us that are using things like provisioning nodes with Carpenter, Auto Node Scaler, we're also using things like the HPA, right? And so the HPA kind of scales by default on CPU or memory utilization. So most people just figure, oh, if I reach 50% or 60% utilization, let's scale some more capacity up, right? And so when the HPA kicks in, it drives a scheduling request down to the node autoscaler, which then spins up more nodes. But in a lot of cases, CPU and memory utilization are not necessarily the best indicators of impending load, right? They're almost a lagging indicator. By the time you see CPU utilization and memory utilization spike, it's almost too late for a lot of applications. And so in those scenarios, you might look to tooling like, if you're familiar with CADA, it's like an eventing bus that allows you to leverage that data to then scale on some of those events instead. And so there's cases where the applications where, maybe the queue depth, if you're using messaging, right, the queue depth increase over a certain amount of time, maybe that's a better indicator of scale because it's before the CPU goes crazy, but you're already seeing those queue depths build up. Maybe that's when you scale, right? Or maybe there's another metric that you can key in off of because you're seeing other event data that's not CPU memory related. So I would recommend looking at some of those like event-based scaling capabilities that CADA provides so that you can see if there's maybe a better way to scale from that.